to dq by dt. I is equals to dq by dt, the rate of flow of charge. The units are what here? Amperes. And dimensions already you know that ampere is the dimension. And also here about the current, we will discuss something that is about the direction from where to where it will be there and all. So whenever I have taken a conductor, for that conductor I have connected a battery. So what happens whenever I close the circuit? Current will flow from where to where? From where to where? Positive to negative, higher potential of the battery to lower potential of the battery. Here I is flowing in this direction. But actually in reality what happens means electrons are moving. This current direction indicates what here? Current, something is flowing from positive to negative you will think. But actually in reality what happening? Nothing but electrons are moving from negative terminal of the battery to the positive terminal of the battery. Why? Because what happens, these are the negative charges. Obviously they wanted to go to the positive side only, so that they are attracting by the positive terminal of the battery, so that they are moving in this direction. But why we will take the current in this direction means these are the negative charges. So you have to take the current opposite to that. That current is known as a conventional current. We call this current as a conventional. This is not the current of electrons. Current of electrons means what? Current of electrons means due to the electron flow. But we are getting in which direction? Opposite direction. Electrons are moving from this side to this side. Electrons are moving in this direction, but we are taking the current in opposite direction. We should not take the current of electrons. You have to take the conventional current. Conventional current nothing but the current which is opposite to the electron flow. This is the opposite to the electron flow. Okay. So that I is equals to what you will get? Nothing but dq by dt. Right? The rate of flow of charge is known as a current. The unit is what here? Ampere. Now tell me, current is a vector quantity or scalar quantity? What is the reason we are having direction right here? Yes, it will not obey the vector addition. It will not obey, it will have the direction. But we cannot say that current is flowing in the east direction, current is flowing in the west direction and all. It is having direction, but it will not obey the addition of vectors. The laws of vectors it will not obey. So only this is what here? Scalar quantity, and also one more name we call it as tensor quantity. Tensor quantity. Tensor quantity nothing but which will have the direction but does not obey the vectors laws is known as a tensor quantity. Otherwise simply you can take it as a scalar quantity also. That is about the basic current here. Always this current is which current here we are taking? Conventional current. Conventional current, that will be always opposite to the electron direction. Opposite to the electron flow direction. That is about the current. After that we will discuss about the current density. So what is the current density means? Any idea? Yes, very good. Current density means, for example, whenever I have taken the conductor here, conductor of area A. Now in this what happening means, in this current is flowing, obviously current of, let me take di is flowing. Now I have taken a small element here, total area is how much here? A, and then I will take a small element of how much area? dA here. Total current flowing is how much here? I, but in this small area how much current is flowing? di current is flowing. From that, from this area, how the area vector will be always perpendicular to the surface area. This is how much here? dA bar, area vector only. For the smaller areas, area is a vector only. For the bigger surface areas, area is a scalar we will consider. Even like angular displacement also. For a smaller angular displacement, angle can be considered as what? Vector quantity only, it will have the direction. For the large angles, it will not have any direction, so that will be a number only, just number only. Now in the same way, here the area vector will be always perpendicular to the surface area, and also current how much is flowing through the surface area? di current is flowing. The current density denoted by the J is equals to what we will do? Nothing but that is di by dA. The current flowing per unit area. You don't think that density means volume. That is current flowing per unit area. J is equals to di by dA. Now here di is equals to what I can write from this? J into dA. Now this product will be which product? That is also important. Which product that will be? always the area, the current should be along with the area vector only. Along nothing but what product you will get? Dot product. Perpendicular means which product you will get? Cross product. Clear? So that here I will tell you about that. For example, the same conductor only I will just cut like this. Like this I will cut. Now, whenever you see the area vector, let me take, I will draw the directions 1 and then 2. In which direction area vector will be there? Along which direction? Always area should be perpendicular to the surface. See that I have taken initially, I have taken the area like this and then I got the vector like this. I got the vector like this. Now what I am doing, I am bending the area like this. Then obviously area vector also changing, right? So that the area vector is changing. This is dA now. This is dA bar. If I take the angle is theta here, then this will be what here? dA cos theta. dA cos theta. Along this dA, a current is flowing. How much is flowing here? di. I said that always I and then area should be in the same direction. Along the I, which area is there here? dA cos theta. So that the density J is equals to di by what you can say? dA cos theta. Then di is equals to J into dA cos theta. AB cos theta is what? A dot B only. In the same way, here also what will get means you will get J bar dot dA bar, dA bar. J bar dot dA bar. J bar dot dA bar gives you how much? J into dA cos theta. You understand? Any vectors, if both are in the same direction means you will get the dot product. If you take the work done also, work done is equals to what is the formula? Force into displacement. Force into displacement means we will take always force along the displacement only. In whichever the direction displacement is there, we will consider force along that only. So along the direction, same direction nothing but you will get the dot product. Perpendicular direction nothing but you will get the cross product. If you take the torque formula, torque is equals to what is the formula? Force into perpendicular distance. Perpendicular distance nothing but always the force should be perpendicular to the distance there, R value. So that only perpendicular means cross product and then along means you will get the dot product here. So here di is equals to J into dA cos theta, that is J bar dot dA bar you will get. So here I is a scalar quantity only, but J and dA bar are the vector quantities here. Current density is a vector quantity. That is about the current density. And by the way, what are the units can be current density? Ampere per meter square. Area means meter square. That's it. Write that. First of all, current. The rate of flow of current, the rate of flow of charge, the rate of flow of charge, the rate of flow of charge. Write the formula. I is equals to dq by dt. Units amperes. Dimensions A. Dimensions A. The next line, current is a scalar quantity. Current is a scalar quantity. Even it have the direction but does not obey vector addition. Does not obey vector addition. So only we cannot take any components for the I. In whichever direction it is there, we have to take in the same direction only. The next line, when a circuit is closed, by connecting a battery to the conductor, then electrons moves from negative terminal to positive terminal of battery, across the wire, but the current flows in opposite direction, known as which current? Conventional current. Known as conventional current. Draw the diagram. First diagram you draw. Next, current density. Current density. The current flowing per unit area. Write everything. Draw the diagrams, take the directions properly. Next one is thermal velocity. If I consider any conductor, what will be happening in that? Due to the temperature, what will be happening? What will be happening due to the temperature? What electrons will be doing? They will be always moving randomly. They will move randomly on zigzag manner, and what they will do? They will be always colliding with each other. They will collide with each other. Then net velocity becomes how much? Zero. That is what in the kinetic theory of gases also you will get that only. The net velocity will become how much? Zero. So here also, whenever I have taken this as a conductor, in that number of electrons will be there. One electron will be always, they are moving in zigzag manner. Some 10 powers of amount of electrons are there. They will be always moving in the zigzag manner due to the thermal energy. By thermal energy, they will gain the velocity and then they will be moving. Whenever they are moving, somebody will come in middle and then they will collide with each other. Whenever they are colliding, at that time what happens? Nothing but once it will collide here, one more time collide and then another time collide, then velocity will not become zero. Net velocity becomes zero. You understand? For example, this hand is having the velocity in this direction. This hand is having the velocity in the opposite direction. Now, whenever they collide with each other, at that time, if their velocities are equal, net velocity becomes how much? Zero. After the collision, they will have the motion again. Whenever colliding, what happens immediately? Yes, very good. They will exchange the momentum. They will exchange the velocities. If the collision is perfectly elastic, means whatever the velocity came here, that will give the velocity to this, and then this will give the velocity to this. So what happens? Nothing but again they will go forward to collide with other. So here also the same thing only will happen. Whenever this hand is coming and then colliding with this, at that time there will be exchange of momentum or exchange of velocity. By that what happens? They will again move and then go with collide with other electrons. So whenever they are colliding, for example, let me take they are gaining own everything is gaining the same thermal energy only, so that they will have all the equal velocities only. So that what happens, it is coming with the velocity u, let us consider. This is also coming with the velocity u, they are colliding. Whenever they collide, I want to ask the net velocity for you. What happens? Net velocity becomes 0. U along the x-axis, u along the negative x-axis. U minus u is equal to how much? It will be 0 only. So always the thermal velocity nothing but due to the random motion of the electrons, all the directions they will be always colliding with each other. Due to that, the net velocity, the net average velocity, the u average is equals to u1 plus u2 plus u3 and so on. Like that, number of electrons are there up to un, that divided by the number of electrons n, it will become how much? 0. Why? Because not only these two, this can have, let me take, this is having the 5 meters per second speed. Then not only second one, something like u10 is having also 5 meter per seconds only. They are moving opposite to each other and then collide with each other. Somehow it will get cancelled only. One is moving along positive x means another will move along the negative x. One is moving in the positive xy plane means another will move in the negative xy plane. In the same way will happen and then all will colliding with each other. Then net velocity becomes how much? Means 0 only. Net thermal velocity is 0. And then why we are discussing this means this will come in the drift velocity concept again. In the drift velocity also we will get the velocity after some time. What is the velocity after some time formula? Kinematics. Velocity after some time, what is the formula? V is equals to u plus at. U is the initial velocity, a is the acceleration and then time is the time taken. Here that time taken is known as the relaxation time. We will discuss that however. Now after this concept, we will have the electron in the electric field. What is the behavior of the electron in the electric field? Once I got the conductor like this, which is connected to the battery terminals. This one is little logical, you have to understand properly. Whenever I connected to the battery, this battery is having the voltage of V. Voltage is having V means across the terminals what is there? Potential difference is there. How much potential difference? V only. However, I said this is having the voltage V means the potential difference is here V, here 0 will be there. Together is it will be how much? V minus 0 is V only again. Now this terminal is, this is 0 means this entire thing is 0 only up to here. Why? Because there is no other resistors are there. If resistors are there and then current flow is there means it will be different. Now this is 0. This is V means even this is also V only. Now this is V, this is 0 here. There is a potential difference created. And also if I consider the length of the conductor is L, then what will be there here? Potential difference is there, length is there. What will be there? What will be produced? Electric field. Electric field, not the current, electric field. What is the electric field formula in terms of potential? What is that? E is equals to minus dV by dx. The electric field will be represented as the negative potential gradient. Very, very important. Based on this number of times question came. E is equals to minus dV by dx. Here dV by dx indicates what? The potential gradient. Electric field is nothing but potential gradient. Potential gradient nothing but potential difference divided by the distance only. So here potential difference is how much is there? V and then 0. V minus 0 is the potential difference. Distance is how much is there? L. So V by L gives you how much? Obviously electric field only. So that it is giving an electric field. Now in which direction electric field will be there? That is my question. In which direction? From where to where the electrons are flowing? Negative to positive. The electron is moving in this direction. Electron is moving in this direction. Always electrons will move opposite to the electric field. Correct? Positive charge will move along the electric field. Negative charge will move opposite to the electric field. So that only here electron is moving in this direction means obviously the electric field is there in the right side direction. Clear? That is not the matter here. Due to this electric field, what happens means this electron will gain some acceleration. How it will gain the acceleration? Because electric field is there. So which force will be there? Electrostatic force will be there. What is the force here? F is equals to what I can write? Q into E. Q is nothing but which charge here? Electron minus E into E. That is the force. If I want to find out the acceleration means what I can write in the place of F? M into A then ma is equals to minus ee, then a is equals to minus ee by m. That's it, finished. So this is the acceleration of the electron in presence of the electric field. How the electric field is present? Due to which one? Due to the potential difference across the conductor of length L. Length L should be there. So potential difference divided by length gives you what? Electric field only here. So the potential difference is there across the conductor of length L here. Due to that only the electric field is generated. Always the electron will move opposite to the electric field. Negative charge will move opposite to the electric field only. So the electron is moving in this direction, electric field is there in this direction. The direction doesn't matter here. First of all, you have to find out the acceleration. For that, whenever here I connected the battery to the terminals, then it is created what? Potential difference. Potential difference and then length of the conductor created which one? Electric field. Electric field created electric force. Force is equals to ma. Correct? So that F is equals to QE and then F is equals to ma. From that A is equals to minus E by m here. Clear? But the battery connected, potential difference is there. Potential difference divided by length. Length of the conductor gives you electric field. Electric field gives you force. Force gives you acceleration. That's it. That is about the acceleration of the electron in the electric field, that is A is equals to minus E by m. Not only in the electric field, in the conductor, by the way here. In the conductor, the acceleration of the electron is minus E by m. Copy that. I think it did not written this one, thermal velocity. Due to the random motion, due to the random motion of the electrons in the conductor, due to random motions of the electrons, not only one electron, all the electrons. Due to the random motion of electrons in the conductor, velocities get cancelled with each other. Velocities gets cancelled with each other. Then net thermal velocity becomes 0. Net thermal velocity becomes 0. Copy that, U average. Next, behavior of electron in presence of electric field. Right. The potential difference across the conductor, of length L generates an electric field in presence of this electric field. In presence of this electric field, the electrons gets additional force. And gains acceleration towards the positive terminal of the battery. copy that. ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಉದಯ್. ಅದೇ ಥರ ಕಾಣಿಸ್ತಾ ಇದೆ. Finished? Next, types of materials. Shall I tell this one? Otherwise not necessary. Types of materials. You know, right, already conductors. Conductors, what they will do? They will allow the current and then offers zero resistance almost. For the insulators, does not allow the current and then offers infinite resistance. Semiconductors nothing but partially allows the current and then offers the finite amount of the resistance. You know, right, already? There is no need to write again, there is no need to waste the time. Now next one is drift velocity. Drift velocity, we will see. Drift velocity, Vd. So here I said already, whenever without electric field, for example, I have not connected any electric field, at that time what happening? Which velocity they are having? All the electrons are having which velocity? Thermal velocity. Okay, due to thermal velocity, what they are doing? They are moving in random motion, zigzag manner they are moving. So here let me take this electron, for example this electron if you take, here it is going and then colliding with another electron, again changing its direction, again colliding here, changing its direction again it is colliding here and then changing the direction and then it is coming like this finally. So number of collisions it will happen and then finally it will come towards the positive terminal of the battery. So without any electric field, it will have the thermal velocity. By that thermal velocity, it will move in the random motion. Whenever I connected the electric field at that time, what happens? It will gain which one here? Acceleration. Acceleration nothing but what is the meaning of that? Acceleration is there means velocity is changing. Velocity is changing. Initially velocity was there how much? U. Net velocity becomes how much? 0. And due to this electric field, what happening? Nothing but they are gaining the acceleration. Acceleration nothing but what? Rate of change of velocity only. The velocity is changing. How the velocity is changing? Nothing but that is v is equals to u plus at. It is getting one velocity due to the electric field, that is the velocity. Let me take v. Initially u because of which energy? Thermal energy. Due to the electric field, it is having how much acceleration? A acceleration. A acceleration is there means velocity is changing. Velocity is changing from where to where? U to v in how much time? Time t. That is the meaning of that. So this time is known as a relaxation time. So what is that relaxation time? Nothing but, for example, if I take this electron is there, here it has already collided with some electron and then coming to here and then colliding with other one. So that this is one collision, this is another collision. The time taken between them is known as a what is that? Relaxation time. The time taken between two successive collisions. Here it came two successive collisions, but you don't consider 3 dots here, 2 dots only. Already here collision is happened, one collision, then next one, this one is a second collision. So these are the 2 collisions. The time interval between them. Otherwise, in normal our mechanics way, we can say that time taken to travel from one collision to another collision also. Okay, this is what it is doing here. And then here gaining some velocity. So that velocity is how much here? V. And then acceleration because of which one here? Electric field. Like that for each and every electron it will be there. For example, if I say first electron, that is the velocity is how much? V1. That is equals to thermal velocity is how much? U1. Acceleration got is how much? A into relaxation time is tau 1. Relaxation time nothing but time between 2 collisions. Okay, any 2 collisions that might be, that is tau 1. Then second one, second electron U2, plus A into T2. Why I am taking A constant? See, A is equals to what is the formula we got? Minus E M. That's it. E divided by M. Electric field is same only. Mass of each electron is same. Charge of each electron also same only. So that will be constant for everybody. So that is V2 is equals to U2 plus AT2, and then V3 is equals to U3 plus A into T3, and so on like that. Vn is equals to Un plus A into tau n. That is for all the number of electrons we will get. Now I want to get the average velocity of this one. That average velocity is known as the drift velocity here. I will tell you the definition of the drift velocity also. First of all, whenever I find the average velocity here, V1 plus V2 plus V3 and so on, Vn. Separately I will take the average values. Average value of this one, average of this, and then average of this. Then this will be how many? N are there. That is equals to, what will get after that? U1 plus U2 plus U3 plus and so on, Un by n number is there. And then plus, what is there here? What I can take common? Acceleration I can take common, then A into tau 1 plus tau 2 plus and so on, tau n divided by n. One thing will become 0 here. What is that? U1 plus U2 plus U3 by n. That is what not thermal velocity I said. The average velocity of the all the electrons becomes always 0. That is 0. Then this average velocity is known as a drift velocity. That is Vd. Vd is equals to what is remaining? Nothing but acceleration into the net time, relaxation time is tau will consider. So here Vd is equals to, in the place of A, what I can write? Minus E by m into tau. This is the drift velocity. And the drift velocity nothing but the velocity with which all the electrons will be drifted towards the positive terminal. Drifted nothing but what? They are just changing the direction. Diversion. They are taking the diversion to, they are colliding, already they are colliding with each other. Due to the electric field, what happens? Nothing but they will divert towards the positive terminal of the battery. So they are taking the diversion, drifted towards the positive terminal of the battery. That velocity is known as the drift velocity. In other words, we can say simply the average value of all the final velocities. Only one velocity is V1. Like that number of velocities I have taken, together I have considered as only one velocity. That velocity is how much here? Vd. Why? Because we cannot calculate for each and every electron separately. So all the electrons together velocity is how much here? Vd, drift velocity, that is equals to A into the net relaxation time. Relaxation time means for first electron 2 collisions time is that one. Second electron 2 collision time. Like that all the number of electrons are having how much means relaxation time as tau here. Minus E by m into tau. This is one formula. One more formula will come in terms of current. That also we will discuss. I is equals to NEA Vd will come. That also we will discuss. So before that you just copy this along with the diagram. Have you written the definition? The velocity with which all the electrons, will be drifted towards the positive terminal of battery. In presence of electric field. In presence of electric field. In presence of electric field. Copy that. ಕೀರ್ತನ, ಕ್ಲೋಸ್ ದಟ್ ಕರ್ಟನ್. ಬಿಸಿಲು ಬರ್ತಾಯಿದೆಲ್ಲ. ನಿಮ್ಮ ಸ್ಟೀಲ್ ಡಬ್ಬಾಲು ಪಾತ್ರೆಲಿ ಎಲ್ಲ ತೊಗೊಂಬರ್ತಾರೆ ಕ್ಲಾಸ್ಗೆ. That side they are getting. Close that side mainly. Enough. Was the tau there? Tau is the relaxation time, the time interval between two successive collisions of the electrons. In the same thing you will get in the kinetic theory also. But there, what is the formula of tau? Generally, what is the formula of velocity? General velocity formula, distance by time. So that v is equals to distance by time we will get. Now here which time we will get? Relaxation time. Distance nothing but mean free path. Mean free path nothing but the distance between the collisions. The distance between the collisions divided by the time between the collisions. So that mean free path is known as the lambda. Lambda means don't take that as a wavelength. That is a mean free path. Okay. The distance between two collisions divided by distance between the time between the two collisions is equals to the RMS velocity we will take. Root mean square velocity. So that here relaxation time tau is equals to what I can say? Lambda by V RMS. This is not necessary by the way for this problems, but you just make a note. Mean free path, this is. Relaxation time you write. Relaxation time. The time between two successive collisions. Time between two successive collisions. Time between two successive collisions. And the ratio of mean free path, to the RMS velocity. Mean free path to the RMS velocity. Drift velocity and current relation, very very important and very confusing also for doing the numericals. Formula will be very simple, but that n will confuse you. What is the n there? What is the formula? Already you know that. Whatever that I is equals to NEA VD will take. What is this n? Number of electrons per volume. Per volume you have to consider always. That is the most main important thing. You have to consider always number of electrons per volume. We'll solve that. So here I is equals to, what is the basic formula of I? I is equals to dq by dt, q divided by t. For example, in our conductor, whatever we have taken the conductor here, this conductor is having the area A and then length is L. Now in that conductor we are having number of electrons per volume. Always you have to consider. So that here original number of electrons is n divided by volume, number of electrons per volume. Q is equals to, what is the formula first of all? Q is equals to n into E only. Q is equals to NE divided by time only. Correct? You know already quantization of the charge. So that Q is equals to n into E. Here n indicates that number of electrons per the volume only. So here capital N indicates number of electrons. So only you might be observed that whenever I was writing about the drift velocity, I have written the small n and then I rubbed. I have taken everywhere capital N only. The reason is we are talking about the electrons separately there. Here small n indicates we are just mixing all the electrons together. You understand? For example, if I take this marker only of area A and then length L, exactly only at this cross section area 10 electrons are there. like that its length is 1 meter, let us consider. So that not only 10 electrons for this area and then length also, area into length also you have to consider. You cannot say that through the entire the conductor you should not take the 10 electrons only. Only at one cross section I have 10. For the entire cross section nothing but what I have to consider? Volume only. For this area into like that areas, how many areas are there? Nothing but L length areas are there. One cross section is A, like that how much length is there here? L length is there. In that number of cross sectional area is there. So that A along the length you have to consider, nothing but always volume. Area into length is nothing but what? Volume. So here small n indicates that number of electrons per volume. That individual number of electrons are how many here? Capital N divided by the volume you have to take. That into E divided by T. I am dividing with volume means obviously I have to multiply with volume also. Then this n by V nothing but what? Small n. E into volume is nothing but what is the formula? Area into length. Area into length divided by T. Then length by time is what? Velocity. Which velocity that is? Drift velocity. That's it. I is equals to NEAVD. That is a relation, very very important. From this, listen again, from this, if I take I divided by A, what is I divided by A? Current per unit area, that is density. Current density J is equals to what I can write, nothing but that is NEVD simply. J is equals to NEVD. That is about the current density, and then here this is the current. And write clearly that small n is equals to, small n is, write in words only, small n is number of electrons per volume. Number of electrons per volume. Capital N is only number of electrons. Only number of electrons. Copy that. Correct. No, actually our formula is here capital N into E. Generally Q is equals to NE nothing but you will get number of only individual electrons only. In that you cannot say that number of electrons per volume, nothing is there, volume is not there in the electric field. So that Q is equals to what is the formula, nothing but N into E. Now for that I want to get number of electrons per volume, so I am dividing with V and then multiplying with V. You just take that is capital N. You take capital N, that is not small. టైం కావాలా 5 అయింది, వదిలిపెడతా. ఇంకొక ఫామ్లో ఉంది, మొబిలిటీ ఉంది. మొబైల్ తీసుకున్నావా? బ్యాగ్లో పెట్టుకుని వెళ్ళిపోరా ఇంటికి. Done. See that here I have written small n before. I is equals to Q by T is the formula for us. Q is equals to what is the formula? Plus or minus NE. There you might be taken small n or capital N. There is no problem in that. Why? Because there is no conductor, nothing. We have talked about in the electrostatics. We are talking about the individual electrons. So individual electrons like that. If I add the n number of electrons of each of charge, different charge, at that time what will get? Nothing but NE will get. N indicates their number of only electrons. Here N indicates the number of only electrons, NE divided by T. Like that I have charge, nothing but this charge is due to the number of electrons, so that NE by T. Now I want to get the number of electrons per volume. I am not having the electrons separately, I have in a conductor. I have to consider entire electrons, nothing but I have to take the volume also. So that the number of electrons divided by volume into volume I am doing. So this number of electrons per volume is small n. Clear? N into E into A into volume is nothing but area into length. By that we got the velocity, drift velocity. And also in the problems they give sometimes the number of electrons per volume directly, small n value directly, and also they'll specifically they'll mention that this number, for example 10 power 20 electrons are there in 1 meter cube volume, otherwise in 10 meter cube volume. Most confusion thing for the students is that only. You have to take, they have given separately means you have to divide and then you have to take. If they are giving combinedly means you have to take as it is. In the whatever the units, the whatever 10 power 20 electrons per volume, 10 power 20 electrons per volume like that they have given means directly you take that as small n only. Otherwise 10 power 20 in 2 meter cube volume like that they have given means you have to divide it. Clear, right? Why? Because you will get the answer is differently. For example, if you say that and then this is same means there you will get 1/2 extra. You are understanding? So that there is a chance of the wrong answers. So you have to identify that properly and then you have to do. And while practicing the problem you can understand that. That is about the drift velocity in terms of current. And then this is the current density. J is equals to NE into VD. And also last one is mobility. Mobility. What is the mobility means? Mobility is mu here. What is that? Divided by electric field. The drift velocity per electric field is known as the mobility. Electron mobility mu is equals to, the formula is Vd divided by E. Clear? That's it. Only one formula is there, mu is equals to Vd by E. The ratio of drift velocity to the electric field. The ratio of drift velocity to the electric field. Drift velocity to the electric field.